Hello.
Hi, hello.
Hi. Can you hear me?
Yep, I can hear you.
So uh, let's begin then. So can you introduce yourself, and after which we're going to solve couple of problems.
Yep, so just interviewing for some practice. I'm going to be using Java. Um, just just looking for some good interview practice.
Okay. Okay. Sounds good. Uh, yeah. So let's begin then.
Okay, sounds
Okay.
good.
I'll take out this. Let's say I give you a number, something like this. Now, if you sort of imagine this number as an image, the entire number as an
hmm
image. Now, oh, sorry. Now, let's say you rotate this. You rotate this image by 180 degrees. So this image, if rotated by 180 degrees, it's gonna be the same, right?
hmm
Now, because like think of you're rotating around this axis, where the axis is going to be at 8 now. If you rotate it, the number is going to be 16891. So, given a number, can you tell me if rotated by 180 degrees, is the number going to be the same, or if it's a valid number?
Okay.
Yeah.
Okay, cool. So just want to ask a couple questions before, I get started into the coding
Sure.
part.
Yeah.
Um, so will my input be an integer?
Uh, yes. Yeah.
Okay. And my output should be like a Boolean value or something like that, true or
Yeah.
false.
Yeah. Yes. Yeah.
Okay, cool. So, will the number be, can it ever be negative or can I always guarantee it to be positive?
Uh, for now, like let's imagine it's just a positive number that I'm gonna give you.
Okay, cool, cool. Is there like a range to this number, in terms of
Uh,
like a maximum number?
uh, it should not. I mean, like you can now consider it as an integer, but I mean, but for an image, it should not really matter, right? Because
Mm-hmm.
yeah. But for now, let's consider it for integers. Yeah.
Okay, cool, cool. Yep. So, is there any time or memory constraints I should be aware of before I start talking about the solution or anything like that?
For now, you can probably, tell me your solution, and later on, if there is an opportunity to optimize, probably we can do it later.
Mm-hmm. Okay, cool. So, well, for my solution, what I'm thinking about, right, is I just want to know whether or not a number is valid if you rotate it 180 degrees, right?
Yeah. Yeah.
So, if you think about like numbers, right,
Mm-hmm.
what I want to do first is I want to point out the numbers that if you rotate them 180 degrees, they are, they're still the same. They're still the same. Or when they rotate 180 degrees, what they look like, right?
Okay.
They correspond to
Okay.
another number, right? So, for
Okay.
example, one got rotated 180 degrees is one.
Okay.
Six rotated at 180 degrees is nine.
Mm-hmm.
Nine rotated at 180 degrees is six.
Mm-hmm.
Eight rotated 180 degrees is eight.
Mm-hmm.
And zero rotated 180 degrees is zero as well.
Mm-hmm.
Um, let's see. So we have one, two, three, four, five, six, seven, eight, nine. Okay, yeah, I think these are our five numbers that when
Mm-hmm.
rotated 180 degrees, they become another valid number,
Okay.
right?
Mm-hmm.
And so what we can do, my proposed solution is
Mm-hmm.
to take the input number, right,
Mm-hmm.
and begin Well, first, before we even get to the solution, what I want to do is create like a mapping between these numbers that I listed here. So
Okay.
ideally, I would use like a hash map where the key value would be 1, right? And then
Mm-hmm.
like the value of the hash map would be the rotated 180 degrees number version of it, right?
Okay.
And then jumping into my solution, what I want to do is I want to iterate through the number, right,
Mm-hmm.
from right to left, right?
Mm-hmm.
And what I want to do is I want to I want to essentially just create the 180 degrees rotated image of it, right? So for
Mm-hmm.
example, for the number input we have here, what I'll do is um, I'll take one, right? I'll go into my mapping, I'll find the 180 degrees version of it, and then I'll add it on to like some, let's say like some variable that holds my 180 degrees um, rotated resulting number, right?
Okay.
And then I would move on to 9. I would check my hash map. Okay, 9 corresponds to 6 rotated, so then I add 6 to the end of this one here, and then I go to 8, and then 6, and then 1, correspondingly. And then after I do that, what I'll do is I'll check to see if my rotated number is equal to my input number, right? And just to reiterate the problem, I want to check if the rotated number is equal to my input number, right?
Okay.
Or
Yeah.
if it's just a right?
Yeah. I
Yeah,
mean,
okay.
yeah. So let's for
And
now,
then
if you rotate
yeah,
it, like if you have any number combination with these, whatever numbers you have listed here, I guess if you rotate it by 180 degree, uh, they are more or less going to be uh, need not be same, but yeah, for now, let's imagine that if the numbers are equal, if the input and output numbers are equal.
yeah. And then so for that algorithm, the
Mm-hmm.
runtime would be equal to n, where n is the length of the number, right?
Mm-hmm.
Because I just have to iterate through the number, and then space complexity will be constant because I'm always holding just 5 elements. Um, yeah,
Like what if the number has like 10 digits or more than 10 digits? Like this can also be um, for now. Let's say uh, 9 1 6 8 uh, 9 1 and then 6 or something like this.
yeah, but it would still be constant because all I need is the mappings. And if I ever run across a number that is not in the mapping, then I'll return false immediately because there's no valid
Okay.
number that equals to my matching.
Okay. Okay.
Yeah, so I'll only always need to hold these 5 numbers.
Okay. Go ahead. Yeah.
Okay, cool. Yeah, so I'm just gonna go ahead and start it. So I'm just gonna do from class solution. Um, I'm just gonna set up my main function, public static void main string rv, right? And then what I will do is I'm just gonna create the function that we talked about, public static
Mm-hmm.
boolean, as we discussed, and I'll call the function is valid, right? Because I want to check
Mm-hmm.
this out. And then I'll just have input value into input, right?
Mm-hmm.
And so, like, I guess like it's more practical sort of talking, like if this is like a class that's to be used, more commonly, I guess I could just have like, or this is like a class to be used in like a larger system or something like
Mm-hmm.
that, I might just have like, my hash map saved as like a more of like a global element instead of just having to create it at every function. But for now, I'm just going to create it in just for this function.
Okay. Yeah.
So it's just going to be a hash map of integers to integers. I'm just going to call it HM for hash map. I also need to import Java utility. I'm just going to import all of them for now. And then yeah, so I'm just going to create this mapping that we have here that is highlighted above in the comments. Okay. 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 Cool.
Mm-hmm.
So now we're gonna get into like the algorithm we have. Um,
Mm-hmm.
I guess one edge case that I guess it doesn't really, my algorithm take care of that, but like one edge case you would have to sort of take care of it. It's like a number like that ends with a zero. But it won't matter. But I'm just saying, if it ends with a zero, then like the zero will go in front. So like for example, like if it was like 1 0, then it would go like 0 0 1 essentially. But the way I'm gonna set up my algorithm, it'll just turn into 1, so it won't be valid. But that's just something to keep in mind of, I guess.
I mean, in this case, like if you rotate it by 180 degree, it would be like 0 0 1, which is not equal to the input. So it's more like
Mm,
going to be false. It's going to be false, right? Yeah.
yeah, yeah.
Yeah.
So yeah, I'm just gonna create this a variable called reverse.
Mm-hmm.
Reverse function as 0, right? And so what I'm gonna do, right? I'm just gonna have a while loop, and it's gonna do while input is greater than 0, right?
Mm-hmm.
Um, and then that I'm just doing while input is greater than 0 is because I just want to grab every number as long as it's valid. So as I start taking the numbers from right to left, eventually I'll end up at 0 after I take the last number. Um,
Mm-hmm.
and so the way I'll do this is I'll grab the rightmost number by just doing right. I'll just call it rightmost, and
Mm-hmm.
I'll grab it by moduloing the input. So input modulo 10. And moduloing it by 10 will always get the rightmost digit for me, right?
Mm-hmm.
And so what I'll do is I'm going to have a check here, because I guess I should have asked this in the beginning. Is like, can any digit be in my input, or is it going to only be these
Yeah.
5 digits?
No, it
Any
can be
digit?
some. Yeah, like 2, 3, 4, 5, 6, 7, 8, whatever. Yeah.
Okay, so I'm just going to check if not hm.contains key
Mm-hmm.
rightmost, then we know right away that this is not a valid number because we can't find a reverse mapping for it. So we're just going to return false because
Mm-hmm.
there's no need to check any further, right?
Mm-hmm.
But if there is, if it makes it past this if statement, there is going to be one. So what we want to do is we want to add to reverse, right? Well,
Mm-hmm.
actually, let me stop myself there. What we want to do is we want to multiply the reverse by 10, and we want
Mm-hmm.
to do that because we want to make space for the new digit we're going to be adding, right?
Mm-hmm. Okay.
So that's what we want to multiply by 10. And then after we multiply reverse or the reverse number by 10, then we want to add the reverse mapping number. So then we add in hm.get rightmost, right? And then the last step is to move our iterator for our input, or essentially just prune our number in a way by just sort of getting rid of the rightmost number that we just used. And the way to do
Mm-hmm.
that is just divide it by 10.
Mm-hmm.
Um, and then that should take care of itself. And then the last thing to do is just return return if reverse is equal to, well, actually, it looks like I need to have a variable to hold the original number.
Mm-hmm.
How else am I going to know, So
Mm-hmm.
orig. So, then I'll have this check here. If it is equal, it'll return true. If it's not equal, it'll return false. And
Okay.
that'll give us
What,
our solution
what's
here.
the space complexity now?
Space complexity is still going to be, I mean, if you think about it, it's still going to be constant in my opinion, because for the hash map, you're always just going to hold 5 values for this function. Reverse, we have these two integers, right? These two integer variables. They're always just going to hold 32 bits. So regardless of the number we have in them, it's always just going to be 32 bits.
Mm-hmm.
And it's never going to change regardless of the input. So in my opinion, space complexity is still constant.
Okay.
Yep. And then we just have like I guess we just have something else. We just have is valid, and we can just
Mm-hmm.
try this number right here. And yeah, I'm wondering if solution needs to be capitalized here. But yeah, I think we can try this out now. Okay, so it's true, and then we can try, like 100. It's a full statement. Then we can also just create like, if you want, I could just create like like a testing function or something that runs through all these things.
Let me how about this? Yeah, because 0 is going to get ignored. So uh,
0, 1, 0. 0 should get ignored, so this must be like 10. 10 should not be equal to 1. An interesting input, because I would say this is an interesting input because
solution should. Yeah.
it's just like, I don't think like Java should have taken this number or something, because it has a 0 in front of it and it's not a valid integer essentially.
So in Java, 0, 1, 0, it's not a valid integer, or does it really convert it to 1, 0? If it does
I mean, I
get
guess,
if it does get converted to 1, 0, then it should return false, right? Because
yeah,
that will be right.
yeah,
I mean, ideally, for the input, like if you consider this as an image, then it should return true, which your solution is doing. But ideally,
yeah. I mean,
the solution, probably because I don't know what exactly is going on in the solution. Like based on your solution, it should have written false, right? Am I missing
yeah. I
something here?
mean, if you if you take it as like a string or something, right? Then yeah, it would have returned, or something it would return true, right? Because it
Yeah,
is equal to the same image. But I just sort of want to see what this input is.
yeah,
I just want to see what this actual input is.
yeah.
'Cause I'm actually very curious about this. 8.
Ah, 8.
Oh,
Interesting.
it. This is interesting. It seems like it's taking the binary version of the number, or no,
Yeah.
not even the binary version. This is like 3 or 4 or something. This is weird.
This is something, I mean, I've not used Java for a while, so even this is interesting to me. Yeah. So, like for now, why don't you change the input as a string, and can you change your solution to handle it?
So I guess yeah, I could do that. I just
I guess
want to ask
probably,
a couple more.
yeah,
Excuse
we
me.
should have probably considered it as a string from the beginning, because like I want to
Yeah,
sort of represent numbers like 0, 1, 0, since I'm talking about images, right? Yeah.
yeah, yeah. I just have a couple questions for that. So like we're gonna change our input to have a string input, right?
Okay. Yeah.
So what that means is so that means like can we have? I guess my question now is like, do we want to know if it's like a valid integer, or do we just want to know if it's equal
They're
to the
equal.
input again?
They're equal to the input. Yeah.
If it's just equal to the input, okay. Yeah.
Yeah.
So in like I'm just gonna have integers in it as well, right?
Yeah. Yeah.
In the
Yeah. The
string.
string is going to be just collection of integers, digits. Yes.
Okay.
And it
Yeah.
could be
So
3, 4, or whatever, or the integers that you have in the map as well. Yeah.
okay, cool. Yeah. So we can definitely just change this to have to figure this out.
Mm-hmm.
Um, so what we can do, just change the input, just the
Mm-hmm.
input, right? Obviously some things we need to change about it. First and foremost, you know, there's a lot of things we need to change about it. So now we can't just have like, the input greater than 0 sort of solution in a way. Um, so what we're going to need to do is we have a string now, for all of our integers,
Mm-hmm.
which, makes sense. So what we're going to do is for our reverse variable that we had before, instead of an integer, we're just going to have an empty string, right?
Mm-hmm. Mm-hmm.
And then for our original variable, we're just going to have it like it's just a constant holder to see what the originally was, right? But now what we will also want to add is um, like a variable called like an iterator, so we can iterate through the string, right?
Mm-hmm.
And we want to set it to the rightmost element, so we can set it to input dot length -1, right?
Mm-hmm. Mm-hmm.
And we can change the conditions for our while loop.
Mm-hmm.
So we can change it to while iter is greater or equal to 0, right?
Mm-hmm.
And I'm just going to go ahead and get rid of a lot of this logic because it's no longer valid in terms of the input as a string.
Mm-hmm.
But for this one, I'm just gonna, leave this empty for now as well, and we'll just get to it after we get to the algorithm. So my solution is similar to what I said before when the input was just an integer. What I'm
Mm-hmm.
going to do is I'm going to iterate from the string from right to left.
Mm-hmm.
I'm going to get the numeric value of that character because I'm assuming I can get my input is always going to be valid and will always only contain integers, right?
Mm-hmm.
So I'm just going to get the integer value of that character. I'm going
Mm-hmm.
to see if that integer value of that character is in my hash map.
Mm-hmm.
If it
Mm-hmm.
is, I'm going to get the reverse mapping of it and then add it to my reverse string. If it's
Okay.
not, yet again, I can return false because there's no point because there's no reverse mapping, right?
Okay. Mm-hmm.
And then I'll just move my iterator to the left one so I can move on to the next character.
Okay.
Yep. And then, it's a bit, I guess you'd say it's a bit more tricky, I would say, because I would say the only difference, the time complexity would be the same, but the space complexity, I would say, would move now more towards n because you need to like have a variable that holds the length of the integer, right?
Mm-hmm. Mm-hmm.
So now it would be like time complexity O of n, and space complexity would be O of n. But yeah, so I'm just going to go ahead and get into it. I'm just going to create a variable called rightmost like we had last time. It's going to be equal to character dot get numeric value of, and this will just get you the number value of the character that you pass into it. And so we'll just do input. And actually, now that I think about it more, I don't really need this original input because I'm not altering the input at all.
Yeah,
I can just
true.
check at the end. Yeah. So you can just do input dot char at. I mean, like, so what, like, it depends on like how clean you want like the code to look. People depend. People will rather have like one liners, two liners, or something like that. But I'm just gonna keep it like more readable. So I'm just gonna have the iterator. So we want to get the input that char at the iterator, and then I'm gonna do in a separate line the deep decrement of my iterator value. I could do it here, but I just want to make it look cleaner.
Yeah.
But yeah, so then I get the numeric value. I check if it's in the hash map like before. If it is, then what I want to do is I want to add to reverse plus equals. I want to add the mapping of rightmost that I have. And then the last thing I want to do is I just want to return reverse dot equals input, so that it returns if the input is still the same or not. Yeah, so then if we just oh well, it doesn't work here. Maybe it should, but if we just have 100 0 0, okay, then we just give it a run. And so, yep, it would be false for this one and true for this one. We get rid of this system.
Okay. So I know that, I mean, it's definitely the solution, I mean, definitely works in O of n, time complexity. Can you think of little more optimized solution? I know it's O of n, but do you have to, create this reverse? Can you do it in? I mean, what I meant is, can you do it in O of one space?
O of one space.
O of one. Yeah.
O of one. Oh, O of one space.
Yeah. Sorry. Yeah.
Okay. Yeah. I can do that. So the way, instead of just creating this reverse input string, right, that we have and just holding it in values and things like that, what we could do instead is we could just have, I'm just gonna put it like in comments, but like so we can implement it later if we want. But so what we could have instead is we could create a second iterator, right? And we have it pointing to the left of it, right? To the leftmost value of it. And then what we can do is we can just grab the mapping, right? Like we do here. And instead of just, adding it onto the reverse, what we can do is we can just turn that into like a char element, right? So like we can, instead of having integers to integers of a hash map, we have characters to characters, right? And then when we get the 180-degree reverse of a character, we can just check if it's equal to the mirror mapping of it on the other side. So for example, for this number up at the top, for example, we can have an iterator or one iterator at one iterator at the other one on the other end. We get the reverse mapping of that. and then we check it compared to its mirror value on the other end. And we say, oh, okay, it's equal. We can move forward one, and then it's equal, move forward one, yep, and it's equal. And then that would be constant time complexity because all we would need is just another iterator.
Okay. Can you implement that?
Yeah. So I'm going to go ahead and change that. Just get rid of that right for now. And so what we want to do is, this will sort of change the time complexity in a way as well, because instead of like O of n now, to be more specific, it'll be O of n divided by 2, because now we only essentially need to go through the input element only half the way through. We don't really need to go through it twice.
Yeah.
Or like the whole thing. We just only need to go half, right?
Yeah.
So I'm just gonna have this other iterator called 2, and I'm gonna change the bounds of it, and I'm just gonna change it so that iterator 2 is less than or equal to iterator, the first iterator we have, right? And also, just to make it a little bit easier, I'm just gonna make all these this mapping now change to characters. All right. Okay, and then we just have one. Right. Okay, and then so now what we can do is change this to a char, and we can get rid of this API that calls character to get numeric value, because right now we just want the char of it, of the rightmost. So we can guess we don't really need to have this as a, I guess we do need to have this, because if it's not in there, then it's already false. There's no point in checking, right?
Yeah.
So now we can just have another char called reverse. Just reuse a name here. And it's just going to be equal to the hash map that get rightmost. And then what we also want to do is iterate, get the char from the left side, like we did for up above. So we're going to have a char called leftmost. It's going to be equal to input.char at iterator 2. And then what we want to do is also increment our iterator 2 to 1. And then the last thing we want to do is check if leftmost does not equal to reverse, then we want to return false, right? And then if it makes through this while loop without returning any false items, then we know the string must be valid.
Okay.
Right?
Yeah. Can you run this?
Let's see. Yeah, it has the same input as the other ones. Yep.
Okay. It works. Just to sort of, nitpick, I would have ideally liked you to sort of, name the variables with the right context. This is just to, sort of let you know that for companies like, Google, or, big four companies you might know, they want the code to be of highest quality, as if you're sending the code to code review. This is just to sort of let you know that, if you're practicing, sort of instead of naming HM, probably you can think of, a variable which gives context to what you're actually, what's actually it's trying to do. So yeah, apart from that, you did good with the two solutions that you implemented. It works. So Let's move on. I will let me give you another problem uh, because we still have time. So,
Cool.
okay. So, uh, let's delete this. Or okay, yeah. Okay. Okay. In Java, it's right. Okay. Take a minute to take a few minutes to go through this problem, and then like tell me the solution, like how you're going to implement it.
Okay. Yeah, let me just give me a second to just read
Uh,
through the problem. Just think about it. Great. Two. Okay. Okay. So from reading this problem, it looks like it's essentially just asking, you know, given a list of pairs that correspond with each other or associated with each other,
mm-hmm.
find all the ones that are all associated with each other, group them all together, essentially,
Yeah.
right?
Yes. Yeah.
Um, yeah, cool. So just gonna ask some questions before get started into anything.
Sure.
Um, is can I always guarantee that the input will always just be in pairs, and I won't ever have like 3 or 4 um pairs or anything like that?
For now, just a pair is gonna just have, I mean, just two elements. Yeah.
Okay, and input will be a list of lists, or will be
Yeah. I mean, it's gonna be like a vector of vectors, right? I mean,
okay. Yeah,
yeah.
yeah, yeah. That makes sense. And then I want to return like a list of lists, sort of solutions
Yeah.
with them all associated with each other.
Yeah. Vector of
Okay,
vectors.
cool.
Yeah.
Awesome. Well, so it looks like I can have duplicates in here. And is there any ordering that you want me to like return the IDs in, other than like, or can it just be any ordering at all?
They can be in any order.
Okay, awesome.
Yeah.
Um, cool. So just thinking about this problem, it sort of reminds me sort of like close to a graph sort of problem in a way, where you have all these edges
Mm-hmm.
and that are associated with these points, and what you want to do is just essentially just find you essentially just want to find forgot the word for it, but it's like the like the groups of nodes essentially after you have all these edges, right?
Mm-hmm.
Um, and so a brute force sort of straight ahead method, or like solution I can think of right away is just to do like first a little bit of pre-processing, and what we want to do is essentially just create like a mapping of edges, right?
Mm-hmm.
And what I mean by that is like make it easier for me to find out what what other nodes are connected to the current node I'm on, right?
Mm-hmm.
Um, and so what I'm thinking is like, to use a hash map, where the integer value, or where the key value will be an integer, right?
Mm-hmm.
And the value of the hash map will be, since there are duplicates I see here, I would say the value of it will be a hash set, and that will just, and what the hash map will represent, like I said, was the number of nodes, or the nodes that have an edge associated with the key, right?
Mm-hmm.
And after we do that, what we can do is we can just do a sort of depth first search, recursive algorithm where we just go through the nodes we have, right?
Mm-hmm.
And if they haven't been visited before, we want to do a depth first search through them.
Mm-hmm.
Add, look at every single node we visit, right? Add
Mm-hmm.
them to a list, right? And then once
Mm-hmm.
that returns, we take that list and then we add it into our resulting list, right?
Mm-hmm.
And then, one thing to keep in mind here is that we want to keep track of all the nodes we have visited so that we don't end up in sort of like a cycle, right? Because it sort of looks like these edges could be undirected.
Mm-hmm.
And we also want to make sure that we don't revisit a group of nodes we've already visited once already. So yeah, that's essentially what my algorithm, that's my solution would be. And it would be the time complexity of that algorithm would be first, would be n, where n is the number of nodes to
Mm-hmm.
create my hash map first, and
Mm-hmm.
then n again to do the depth first search to gather all the groups of nodes together. So be 2n, and then my space complexity will be n as well in order to hold all the nodes.
Mm-hmm.
Yeah, and then I think that's a solid solution that would do this. Yeah. Yeah. So should I just go ahead and start? Go ahead and implement this.
Sure. Yeah.
Okay. Cool. So I'm just gonna go ahead and do the same thing for the class solution. I'm just gonna set my main function. Take void main string argc, and then what I'm gonna have is I'm just gonna have the function we talked about. So
Mm-hmm.
public static, and I'm going to return a list of lists. In Java, we have lists,
Okay. Yeah.
similar to how C++ has the vectors. You return a list of arrays, an array list, which is essentially the same thing as a vector. Yeah. So list of integers. And what I'm going to have is I'm going to call it categorize IDs. Categorize ID.
Mm-hmm.
And then I'm just going to have the input as a list.
Mm-hmm.
I'm just going to have this as input.
Mm-hmm.
Right. So what I want to do now is I just want to create that edges mapping that I talked about in the beginning.
Mm-hmm.
So I'm just going to have a hash map. I'm just going to go up here. Import Java. I think I'll use the hash map, honestly. I'm just going to import all of them here. And then I'm just going to have an integer with the value of the hash set.
Mm-hmm.
And, I'm just going to call it edges.
Mm-hmm.
Right. Then now what I want to do is I want to just go through my input and just create the mappings, right? Mm-hmm. So I just want to go through list of integer. What I want to call this is I'm just going to call this pairs.
Mm-hmm.
Right. And I'm just gonna have an input right here. And like I said before, it looks like this can be sort of an undirected sort of graph in a way. So I'm just gonna have to do like dual mappings. Well, thinking about it, I could no. I'd rather have it as undirected graph. I think it makes it slightly easier.
Yeah, it makes yeah.
Yeah. So I'm just gonna do input if absent. This will essentially just put in my hash map the hash set if it's not already there. I just copy this part. Just do it again for edges, first pair. And now what I want to do is I'm gonna do edges.get pair get 0 dot add the second one or the other one. And then I want to do the same thing. Just do the same exact thing, but I'm going to do it reversely this time. Right? Okay. Now that we have that, we have our edges. So now we want to make the cursive sort of function we have, right? Yeah, so we want the recursive function. I'm just gonna go ahead and create the recursive function first. And then I'm gonna come back to this main function to create the logic that sort of implements or sort of sets up the recursive function, the depth first search function.
Yeah.
Right. So I'm just gonna have it as a void function, and I'm doing that because what I plan to do is essentially I'm going to have a list object in my recursive function, and what this recursive function would do was just add in the nodes I see into that list object that I have as an input. So here's a couple variables that I want to have as input. First is current node. Second, what I want to have is the edges, so I can, yet again, like I said in the last time, I could, if this is a function or a class that's being, or a function that's being called a lot in a specific object, I could just have the mappings already created and, as a global sort of variable within the class. But yeah, I'm just going to have it as a local. Edges. And then what I want to have next is my list of integers, which will hold all the nodes I've seen so far. And I'm just going to call this products. And I'll just do the current node, current product, just to help. And then the last thing I need is, something or like a hash set to prevent me from going in cycles, because it's a doubly or it's a it's an undirected graph. So I'm just gonna use a hash set of integers, and I'm just gonna call it visited, right? And so in this recursive function, what I'm gonna do is I visit this node, right? So I'm here, so I'm just gonna have product dot add current product, right? And then I also want to add this product to dot add to my visited list, right? And now what I want to do is I want to go into my edges list, and what I want to do is iterate through all the edges connected to where I'm currently at, and I want to check first, have I visited it before? If I haven't,
Mm-hmm.
then I want to recurse down that node or that product.
Okay.
So I'm just going to have an image called edge, and I'm just going to do edges dot get current product. And I'm just going to check if not visited dot contains edge, then I want to recurse down this part. Then I'm going to call get node edge edges products visited, right? And then since it's a void function, I don't really need to return anything. It will just end on its own. It doesn't after it goes through all the edges, or if none of the edges, or if all the edges associated with this product have been visited, it'll end on its own.
Okay.
So I'm just going to go ahead and quickly, we're running out of time. I'm just going to go ahead and quickly implement the algorithm to set this up,
Sure.
this recursive function up.
Sure.
So what I want to do first is I want to I'm just going to set up my list of lists, and I'm just going to call it categorize products. And I'm just going to set it to a new array list, right? And one other thing that you have to keep in mind of here is similar to how we have a visited hash set to keep track of the nodes we visited before, in order to prevent repetitive searches for the same group, we want to have another hash set as well to let us know what nodes we have visited, and this will just make sure that the algorithm doesn't have repeated groups. So I'll just call this visited nodes. And while thinking more onto this hash set we have here is actually going to be this hash set that we pass into it. So I'm just going to call it the same name. And it's going to be like that because we want to, it will help us reuse a data structure, as well as it just makes sense that we pass this visited hash set into a recursive function, because we want all the nodes that any recursive function has visited, so that we don't repeat ourselves, right?
Yeah.
So now, the finishing touches, int, I just want to iterate through my hash sets or hash map keys, which essentially hold all the unique nodes or all the unique products. So edges, key sets, and then if not visited dot contains product, I want to have a list, right, of integers, and this is a list that will be filled up by my recursive function. Just call it product to have consistency. List, and then I'm going to call my recursive function product edges product visited. And then the last thing I want to do is I want to add it to my categorized products dot add product. And then I want to return categorized product, and then that will return the function for me. And yeah.
Okay. Can you
Yeah.
try it with a
Yeah.
sample input?
Yes. Um, so Java's a bit verbose, so I'm just gonna have to like add on the
Yeah, yeah.
pairs. I could just add on like yeah. So it's like I just have to create like a list of lists. Just call it input.
Can't we sort of initialize in the declaration itself, as in no in Java? I'm forgetting it. Like it's been a while since I used Java, so
Yeah, I think the closest thing you can do for initializing a list is uh like have like an array because you can
uh,
initialize arrays with
okay,
objects, and then you have to like instantiate the
okay,
array into a list.
yeah. So
Um,
due to like a shortage of time, but I just want you to focus on this solution and get node and can you think if this if it's doing the right thing, or can you uh, see where you could probably um, in the sense that like you're basically adding the products no matter what, and you're also adding it to the visited. Can you think of sort of correcting this? I do see an issue with this function. Like for example, like I go to one, and then I go to two. I go like from two to five. Okay, then you basically here in this loop you again pick up the edge, which is a two, and then you come here and then you again add it to the product. So can you think of a way to sort of get that function right?
um, what I can think of, right, is to change sort of the ordering of how I do this. So one way to do this is, well, I think there's sort of two ways to do this. One way to do this is if visited dot
Mm-hmm.
contains
Mm-hmm.
current current product,
Mm-hmm. Yeah.
then just return. That's one way.
Mm-hmm.
Um, Another way is to just do this. Just add it as soon as you get it, or as soon as you see it. So like hash sets have a function called add, right? And add will return true if it's not in the hash set, and false if it's already in there.
I guess this
So what
kind.
I could do,
Yeah, this is the condition that I'm gonna actually I was asking for, and you wrote it. Yeah, this is good because I mean I guess without this, I believe if without this condition, probably you're gonna have a lot of duplicates in the products array. Since we are, since we are not really verifying with any input, I just wanted to sort of let you know that that without this condition, probably I guess we might have duplicates in the output that you might you might that you're returning. So
yeah,
yeah, hello, 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 hello.